Good evening, everyone. Thank you for patiently waiting. We are sorry for the delay. So, good evening and welcome to the second edition of CodeUp in Chennai. So, this is, as I said, this is the second edition. We have done a blockchain session before this, and we got a tremendous, amount of visitors for this, and we are hoping for the same, and we saw the same, and that's why we are here as a second edition for the same topic. So, as you all know, PayU is one of the leading payment service providers. We are across 17 high growth markets, including India, across sectors like SMBs, airlines, startup, and of course the startup community. So, we conduct these series called UpStart and CodeUp. UpStart is for the startup entrepreneurs, and CodeUp is, as you all know, for developers. So this is a way of us reaching out to the startup community, and here we have even the students. So this is an outreach for them as well. So welcome once again, and we start off this session with two of our speakers, that is Satheesh and Seetharaman. So Satheesh is the Associate Director at Depository Trust and Clearing Corporation, and he's the contributor to the Hyperledger project as well. So Seetharaman is Associate of Projects at Cognizant, and he's a developer, and he's into blockchain, Ethereum, and all of the other cryptocurrencies and its implications he can talk about. So we are starting off with Satheesh as our first speaker. So Satheesh, another additional information, he's one of the beginners who started talking about blockchain in Chennai. He has organized many such workshops and talks as well. So, and also we are trying to limit the questions to 2 to 3 after their session, and you can also ask them more such questions during the networking session, which we'll open up once both the speakers are done. So Satheesh, over to you.
Good evening, guys. Thank you for the warm welcome. That was nice. And I had something prepared in my mind. By looking at the crowd, I'm going to go off script. So, so please bear with me for that. The slides that I'm going to present may not be very relevant for the crowd that is here. So I'm going to go off script and then try to explain you on the board. Am I loud enough for you guys without the mic? No?
Yeah.
Okay. So yeah, to start with my introduction, I'm Satheesh Kathamuthu. I work for this company called Depository Trust and Clearing Corporation. So we do the stock settlement and clearance of all the equity stock in the United States. And we are also the depository for all the equity. Compare that to India, this is like the NSDL, the Clearing Corporation Limited in India. So to draw a parallel, and I graduated out of this university. So I went to college somewhere nearby, a few blocks away from here. So it's good to be back here in the campus, and I'm nostalgic about it. So yeah, let's start with this. So you can if some terminologies doesn't make sense to you, stop me and ask questions. As often as you can, I suppose. And let's start with that. I want this to be interactive. Like, if you don't understand something enough, and if something goes over your head, please stop me then and there. I'll try to, I'll try to explain it better. And another thing, I don't want this to be a lecture. I've sat in many lectures during my college, and how much I hated, firsthand. So let's not do that. Yeah, let's get started. So yeah, what is blockchain? Before that, you all know what a ledger is, right? In the accounting terms, a ledger is something that keeps track of all the expenses, meaning all the transactions that are happening. Like if I send Seetharaman 100 rupees, that will be recorded in the ledger. Now that I sent 100 to Seetharaman, and traditionally this ledger is sort of maintained, in a bank or in a community bank or in a central bank. So if you look at it, in the hierarchical way, there's the RBI that sits on top, and there are these big banks that directly work with the RBIs, and there are other smaller banks that connect to these regional banks. For example, ICICI will have a direct account with RBI, and some community banks may not have that access. So it has this hierarchy, and everybody maintains their own ledger. So for example, if ICICI nets so much amount with State Bank in a day, that will be recorded at the RBI's ledger. So to give you the background, so that is the ledger. That is something that keeps track of all the transactions that happens in the system. So when I say the system, this is the cash transaction system, the cash market in India, like the financial cash market. And the same thing will apply for the stock market. Like for example, if I take the example of the National Stock Exchange, if I own 100 shares of something, the ICICI Bank, that will be maintained by the depository under NSE, that's the NSDL. So they maintain that I own 100 shares of ICICI, and if I were to sell that to somebody, and that has to change hands, and I should also get the money. So there are two transactions happening here. One is the cash transaction, the other one is the exchange of shares. So these two things will be tracked separately, and so in the market, we call something called the risk. So what if I promise to give him the 100 shares, but I don't deliver it, meaning I don't have it. If I do a naked selling, I don't have it, or if I don't obey my promise, or if I go bankrupt. So this is a risk. So there are systems put in place to reduce the risk. So yeah, coming back to this topic, a blockchain is something like a ledger that's going to record the transaction that is happening, and since we do digitally, it's a digital record of all the transaction happening, and it's chronologically updated. So meaning, if I do a transaction first and somebody else, Seetharaman does a transaction next, so the order in which it is going to appear in the ledger is in the same way. So by date it is going to get updated, and it's distributed. So coming back to this distributed part, remember how I told you, like RBI has its own ledger and the individual banks will have its own ledger. That is something that's totally different here. So if I can get the marker. Yeah. Okay, so in traditional system, the RBI will sit here and they maintain this record. So they maintain who does what transaction with somebody, and they record all this. And ICICI, this entity will have its own ledger that is going to maintain the transaction that happens at the bank level. And let's say SBI, they also maintain this ledger, similar ledger that is pertaining to their accounts. And in the end of the day, if somebody from SBI sends money to ICICI, from this bank account to this bank account, so it doesn't come here directly. So the way it happens is that they record all the transaction that happens between ICICI and SBI in a day, and then in the evening they do something called the netting activity. So they take it down to a single question, and that will be sent to RBI that ICICI owes so much money to SBI or vice versa. So after deducting so much, for example, there are 10 transactions from SBI to ICICI, each for like 100 rupees and at 10,000. But the vice versa, there are about 8 transactions to SBI, each 100 rupees. So that's 8,000. So this will be netted to a portion of 2,000 rupees. Only that gets transferred. So this is the concept of netting, and this will go through the RBI system. So if you look at it, RBI is going to maintain its own ledger, ICICI is going to maintain its own ledger, and SBI is going to maintain its own ledger. Now coming to the distributed part, let's start small. Okay, let's say we have 4 participants. When I say participant, 4 actors in the system. Like this me, Satheesh, and Jayesh, correct, and Jay. Okay. So there are 4 participants. Satheesh, Seetharaman, Jayesh,
and Jay.
Jay. Okay. So J. So there, these are, let's say these are the 4 actors in the system, and we get to transact money amounts ourselves. Let's say I have 100 rupees. Let's start with 100 rupees each. Okay, so this is our account balance starting. Now let's bootstrap a system where everybody has 100 rupees. So I buy something from Jayesh and I owe him like 10 rupees. Okay, what happens now is I tell to everybody that I owe Jay this 10 rupees. Okay, so everybody will deduct 10 from my account. So everybody maintains 4 account balances. So all the 4 people are going to maintain the balances of everybody, and they're going to record that Satheesh owes Jay 10 rupees. And this is going to happen for all the activity that happens in the system 4 days. For example, like, and if Jay owes another 10 rupees, so this will be recorded. So J1 to J2, 10 rupees, and if Seetharaman owes 10 to J, that's going to be recorded. So now when you look at it, I owe him 10 rupees, so my net balance should be 90, and he owes 10 to J2, and this will be 110, and J1 gets another 10. Yeah, J1 gets 10. So he will be 90, and he will be 110. He will be 90. He will be 120. So this is the end of after all the activities happen. Since all the transactions are sent to everybody that are participating in the network. Let's say if J2 says that he has sent the money, but he didn't actually send it, meaning he owes him money, but he didn't send it. But he says that I've sent it to everybody. That gets recorded. And essentially, since this is a digital account, there's no physical exchange of money. All we maintain is these balances. Make sense? So when you look at it, this is a distributed system in a smaller scale. So everybody maintains that ledger. Everybody maintains everybody else's balances. So no matter how many actors are available in the system, everybody is going to maintain all the transaction and also all the balances. So this is a distributed system in a small scale. So when I say distributed, this is what it actually means. So, and cryptography is sealed record. So, okay, so now coming back to the ledger, okay. So why does it have to be cryptographically sealed? So this is a blockchain, very similar to the linked list. You guys must use in your programming. So what you see is a blockchain, meaning a block is going to have a set of transaction, and it is going to have a header, and comprising of all this, it goes through a hashing function, like a SHA-256 or SHA-128. So that's a hashing function. When I say hash is one way. So given the data, let's say this is a hashing function. Given data, it outputs hash. The reverse is not possible. Okay, so this is a one-way hashing. So what is going to happen is it's going to hash the data, and that hash will be present in the next block that is going to get appended. So this is the first block that gets created, and this is the second block. And this block is going to have all the pending transaction and also the hash of the previous block. So when I say the hash of the previous block, it represents the entire block. So when something goes through a hashing function, and the output hash represents the entire data in the hash. Okay. and this block is going to also have the hash of this block, and so on. So in the next one, it is going to have the hash of this block. Okay. So when I look at it, if something changes here, the hash will change. Now the hash of this block will change, and it will not match the hash that's stored in the next block. So in the same way, like if I have 1,000 blocks before this, if something were to change in one of the blocks, everything else will fail. When I say fail, will fail to validate. Okay, when something changes here, all the remaining hashes will be invalid. When we do the calculation, so we can always say this block is invalid. So that has a beautiful purpose. Remember, I told you that the block is going to, every block going to store all the transactions that happened. So if I say this transaction happened, and then later come and say that I didn't do this transaction, if I somehow manipulated this block to remove my transaction from the net, from the list of transactions, that is going to reflect on every other block. So I cannot, once something happens, I cannot go back and modify it. So that is the beautiful application of the the hash here. So so when something gets tampered in the previous block, you can always come back and say this is not a valid block. This is wrong. So that is the purpose of cryptographically sealing a transaction. So put together all this is your blockchain. Okay. And so this has been around for some time. This blockchain has been around for some time. It started with the in the earlier days. There are a lot of other things that came before actually Bitcoin, and a lot of things didn't get succeeded. And Bitcoin is what brought this blockchain to the mainstream. So that happened. It started sometime in 2009 and became mainstream around 2013. In the same time, in 2013, 2014, something else came. So that's the Ethereum. So Vitalik Buterin, who is the founder of Ethereum, he came up with a white paper. All we are doing is, prior to that is only capturing this transfer of a coin, like transfer of cash from one entity to another entity. He found a way to abstract this. This can be used for other things, apart from cash. So that then came Ethereum. So he found a way to basically abstract this. Why don't we do this same transfer for other asset classes? For example, stocks, bonds. This can be done in a similar way for other asset classes. Then he went one step further, to create this Ethereum network, to abstract entirely, and then introduce something called the smart contract. So we'll talk more about the smart contract in a bit. So to come back here, this is built on top of cryptography. I explained how cryptography fits here, and peer-to-peer networking. So since this is a distributed network, so things has to be exchanged between different nodes. So that's where the peer-to-peer networking part comes into play. Game theory. So why does game theory comes into play here is truly very remarkable, because since you have all these actors participating in the system, and to come to a consensus, meaning to come to something to agree upon, to not play as a bad actor, only if you achieve the Nash equilibrium, so you will come to a state where everybody will participate in the system, that's beneficial for them, and also that's not harmful to others. So if you participate in that system in a harmful way, that's only beneficial to you. That's going to harm the network. You are negatively incentivized. So if that makes sense, yeah, I can touch upon that a little more. Okay, so yeah, this is what blockchain for starters. This is what blockchain is. So did any of the topic that I discussed, any of the terminology that I used that then doesn't make sense, I can go in more in depth into those topics.
You have drawn some blocks, right?
Mm-hmm.
Is this a single guy's transaction?
No, every block will have multiple transactions. So when
Is it a single person's transaction?
not single persons, all the transactions that happens in the system. So for example, if it is a Bitcoin network, yeah, that is a blockchain network. So all the transaction happens in the Bitcoin network will be recorded in a block. So in Bitcoin,
So how many network can be accommodated? So how many people?
n number of people.
N number of
People. So since this is a truly distributed system, there is no limit on the number of people that can participate. But there are other implications when there are a lot of transactions happening. There's this scaling problem that almost all the network now faces. In Bitcoin, I think it can take about 6 transactions. It can process about 6 transactions per second. The limit is because every block size is limited, and so when the block size is limited, it can accommodate only so many number of transactions. Let's say if it can accommodate, so in the case of Bitcoin, it creates a block about every 14, every 8 minutes, and it can accommodate about 200 bytes. So it for every second it can process only 6 transactions. That's the limit that is there in the network. In the case of Ethereum, it can do 16 transactions per second or something like that. So very close to 1.
1,000 person is in a network.
Mm-hmm.
So each block contains 1,000 people.
It will not contain 1,000 people. Let's say I am in the network. I don't do any transaction.
So
I will not be there in that block. So yeah, for the recording, the question is, if there are 1,000 people in the network, will all the 1,000 people be recorded in each block? The answer is no. So only if I do some transaction, only those transactions will be recorded in a block.
what if 1,000 people do the transaction at the same time?
If it happens, all the transaction has to be accommodated into different blocks. So let's say if one block can have about 500 transactions, okay, hypothetically. So the activity that happened in that time period will be accommodated into 2 blocks. So 1,000 transactions happen, okay, but the block can accommodate only 500 transactions.
Maximum.
Yeah. Okay. So we need 2 blocks. So it will create 2 blocks, but it will create in that same interval. So every 8 minutes, it will create that interval. So it will have this pending transaction list. Okay. So when a new block gets created, it is going to compile a list of transactions from this pending transaction list, and then figure out how much it can accommodate in a block, and then only writes those transactions in a block, and then waits for the next block for the pending transaction. Make sense? Okay. So if I were to explain it a little more, let's say a page can contain like 10 lines. Okay, it can record 10 lines. If if I were to write 20 lines, what will I do? I write 10 lines in the first page and then write the next 10 lines in the second page. Same thing here.
So it will keep on going this way.
It will keep on going. So that is a problem in the Bitcoin network. The pending transaction list keeps going. Okay?
So there's no limit for the memory.
No. So pending transaction, so yeah, there's no limit. So the way you achieve, let's say if I send some money to Jay, and this is a priority, it cannot wait forever to get confirmed. When I say get confirmed, to be returned to a block. Only if it gets returned to a block, the actual transaction is recorded. Unless it's otherwise it's not. So if my my transaction is important to me, I pay a higher fee, a transaction fee. I say that I'm willing to pay a transaction fee of so much for my transaction to be recorded in priority. Okay.
So you get the money.
Okay. So remember I told you about the incentive part. Okay. So for all the actors that are participating in the network, okay, why would they need to participate? Okay. So they need some incentive. So why do I need to run a Bitcoin network, a Bitcoin node? Sorry. So I need some incentive. So why do I need to run my computer? I get something out of the network. So the way I get something out of the network is something called the block reward. Okay. So remember I told you that this is a distributed system. Who creates these blocks? Anybody in the system can create that block. Okay. So when I say anybody, so how does the system say which block is right? Okay. So for that, there is this concept of proof of work. Okay. So proof of work is nothing but to prove that I did some work. Okay. That's pretty much it. So as the name says. So if I want to create this block, okay, if I want to create this block, I have to show the network that I did some work. Okay. So this proof of work has to be in a way that it's difficult to find the solution, but easy to verify the solution. Okay. So if I were to say again, so think of it like a puzzle. Okay. So that puzzle should be very difficult to solve, but easy to verify. Let's make sense. Okay, let me say it this way. So so given a puzzle, that's easy to verify. So if I give you a puzzle, what is 2 times 2? It's easy to calculate and also easy to verify. Okay, but if a puzzle is difficult to calculate but easy to verify, that is what that is the proof of work algorithm that's being used. Okay, so that requires computing power to find the solution for the puzzle. So if I own a computer and I participate in the Bitcoin network, and I'm able to find that puzzle by compiling this transaction, and then I create this block and I say this is the block and this is the answer to the puzzle. And if I were to find that answer first and I say, hey, I found the answer, this is the block, take it and then append to your ledger. So every node maintains its own ledger, and let's say every node has 2 blocks now, right? And there are about 10 pending transactions, and let's say I try to find the next block, and I found it. What I do is I add this to my 2 blocks I have, and then I say to everybody, hey guys, this is the new block, and that has these transactions, and everybody else will verify that whether the solution is correct, meaning the answer to the puzzle is right, If they find it to be right, okay, I agree, this is the correct solution to the puzzle, and then I append that third block to my ledger. Okay. So yeah, if I were to find this block, I get something called the block reward. That is going to contain all the transaction fees that I captured as part of all the transactions that I compiled, and also a mining reward. So that's something else. Yeah, different network practice differently. So that is the mining reward. So there is this incentive for people to participate and people to get incentive out of it.
Like you wrote about the proof of work algorithm, right? So Ethereum uses proof of work, but there's a new like currency called as Monero that doesn't use proof of work, but instead, so basically as a miner, in order to solve that complex mathematical equation and to get a 51% of votes to approve a particular transaction, this entire thing doesn't happen. So there is no concept of miner. So there are no miners, but then so let's say I'm making a transaction. So I'll be the miner for that particular transaction. So how does that work in that scenario? Because
Okay.
I'm not completely understanding.
So yeah, that is something we'll cover in a bit. Okay, to answer you now, there are other algorithms that are being developed. There is one called proof of stake. So there is another thing called the zero knowledge proof. Zcash. Yeah, Zcash uses zero knowledge proof. So when Bitcoin came up, all these new cryptographic algorithms didn't exist. Whatever Zcash uses didn't exist. Zcash uses something called the Z-Snark. It didn't exist then, so there is no way of using that then. So they had to use something else to solve that problem. And now with the advancement in the cryptography, there are other things that are being worked on. So proof of stake is something, instead of doing this computative intensive calculation, I bet so much money that to say that this is right. So if I say, I have one computing power and that gets one vote in the system. If I were to draw a parallel to the proof of stake, if I have one unit of currency, I get one vote. Okay. So yeah. Okay, so I think I've covered some bits of it. So blockchain 1.0, when it came up, it was only the currency part of it. Next came the contracts. So I'll talk a bit about the contracts here. Okay. So speaking of contracts, let's say in a system, if something were to happen, something else has to happen. Let's say if I'm buying a car from Jay, okay, and I have to give Jay the cash, and he has to give me the car. Okay, these two things have to happen, in an atomic fashion, so that we avoid the risk. Remember the risk I told you. So if I send him the cash and he doesn't give me the car, then I'm at a loss. Okay, so these things happen in an atomic fashion. So one transaction cannot happen without the other, completing. To avoid this problem, smart contracts are nothing but contracts that live in the blockchain system that automatically takes care of this thing. If one activity were to happen and something else has to happen because of that, you can code that into the blockchain system and then make it happen automatically. For example, if an insurance payout has to happen if I die, if I die and then the payout has to happen, so that can happen automatically. But in the current system, somebody has to file a claim, and get that process done and then get the money out. So think of it this way: if those things can happen automatically, if the system can has a way to figure out whether somebody is alive or not, and whether somebody has a policy or not. If these two things happen and a state change happens and the money gets paid out. So that is essentially smart contracts. Basically writing these activities that have to happen when something else happens. If you can write that and put that into the system, that is what you call the smart contracts. So earlier I told you, Ethereum is what that brought this abstraction. Earlier it was only meant for this cash transfer purpose, and Ethereum brought this to this abstraction layer where anything can happen, and it took it to the next level where you sort of see the Ethereum network as a global computer. So everything lives on the Ethereum network, and it is one computer, like one big giant computer, and all the smart contract lives in that giant computer, and things happen automatically. Like if I get something, and let's say it's a complex contract. I'm trading in option stock, and to come back to a simpler example, let's use the car example, and then I'm buying the car from him, and then he is using that money to buy something else from another person. Okay, so if this were to happen in the system, and these three transactions if that can happen automatically, that's a win for everybody, right? We reduce a lot of risk out of the system. So that is what smart contract does, and that's what Ethereum tries to achieve. That's the giant computer exposure, and so blockchain 3.0 took it to other systems into other areas. So not only finance, but in healthcare, and government, and every area that it can. Okay, so the global computer I told you about, all these smart contract lives in the system, and it sort of trickles down. When one state change happens, the other state change automatically happens, and so on and so forth. Okay, so moving away from proof of work. So I sort of explained to you what proof of work is. So because of the proof of work, there are a lot of repercussions in the environment and also in the system. Because of that limitation, the problems I told you about, the scaling problems, it can accommodate only so many transactions in a time interval, and it attracts this huge transaction cost. Okay, in January sometime, if I were to do one transaction in the Bitcoin network, and I have to pay a fee of about $37. If I were to even send $1 across, I have to still pay $37. So it doesn't make sense. This system came into existence to avoid these transaction costs, and banks were making money out of us. So it came out of it. So, but the reality is the transaction cost is high now, and it cannot process so many transactions per second. Visa, the payment network, process about 45,000 transactions in a second. This one, I think 6 in a second. So that is the amount of.
Why? Because Ethereum blockchain is so much powerful. It is powerful than 500 supercomputers combined. Why is?
Okay, the question of why. So everything put together is so much computing power, but every node that is participating in the network has to have every transaction that happens. So now you understand the problem. So all those information has to be present with everybody, and they should be able to validate it. Not only present, but validate it as well. So that's where the scaling problem comes. And it's, if you look at it, it's one blockchain. So things are happening serially. Yeah. So things are happening serially. Now if I were to parallelize this, let's say I start with one main root node, and then I have n number of nodes that can track this transaction parallelly. So with this, you can exponentially increase the amount of transaction that you can process in a time interval. So since things are happening serially, it's just one blockchain. Things are very slow now. So that's the scaling problem. We are that these guys are facing in the system. Reducing transaction cost, I told you about, increasing transaction throughput. So there are different approaches that are being done to solve this problem, the scaling problem. One is the sharding approach. Now, sharding is exactly what I just explained. So, shard this into parallelize this creation process. If you can, the word sharding comes from database sharding. So, in that sense, so they're trying to parallelize things, but always have a provenance that can be validated at any time. So if I were to start things parallelly from the beginning, then there's no concept of being able to validate, being able to tie back to one root node. That concept is lost. So that's what they're trying to do with sharding. And layer 2 approaches is something that almost all the networks are working on. If you've heard about Lightning Network in Bitcoin, or Radar Network, or the Plasma in Ethereum. So Plasma is an interesting concept. Okay. So I'll explain what this off-chain payment channel. So you have this one block, this blockchain that needs to record all the transactions that happen. Okay. Let's figure out a way to move all these transactions happens. Let's say if I'm running a payment system on top of it, I can create. I maintain a separate blockchain that is going to record all the transactions. It doesn't have to go to the main blockchain, mainnet blockchain, but I'm going to record this, and in the end, towards the end of the day, I'm going to say take a hash of everything. Meaning when I do a hash of the last block as of that day and record that here, that's good enough. That's good enough. Meaning this hash is going to prove that all the transactions that happened before, and if I record that alone here, that's good enough to validate all these blocks. So that is what this layer 2 approach talks about. And Plasma has an interesting feature called anchoring. So if something were to happen in this in this layer, so this layer is compromised, and I hold so much money in this layer. Okay, because of this concept of anchoring, I can always go back to the main network and then prove that I had so much money in this off channel. Because of this property, Plasma is interesting. It is actually not recording all the transactions, but I can always come back to saying that this will be my balance in the end. So that's an interesting property. Yeah. Any questions so far?
You told that all the transactions are getting stored, right? So what if I want to search my one particular transaction? Can I do that?
Yeah, you can. So every transaction will have a transaction hash. So that's the transaction ID. You can always go back anytime, find that transaction, and find out what happened. So if you were to pay somebody else, your friend, 100 unit of money, that will always be there.
So what do I need? I need transaction ID.
You need the transaction ID.
Because other than that, without that, I can see anyone's transaction.
And if you were to go to your account address, that's going to have all the transactions that happened on your address. So even if you have your transaction address, that's good enough.
One more thing, what if I made a wrong transaction? Let's say I'm supposed to send you 50 rupees, but I send you 100 rupees. And once it's on the chain, it's on the chain. I cannot take it away.
Yeah.
How do I handle that?
You cannot handle that. So you have to make a subsequent transaction to correct that.
Why? Why
So that's the beauty of immutability, right? So blockchain is something that's immutable. You cannot go back and change things. So if you were to go back and change things, okay. So let's say, we have these many blocks. Your transaction happened here, but these many blocks got created afterwards. You were to go and modify something here. All these transactions, all these blocks has to be recreated. Now how much strain that puts on the network. If the system is where to allow that, things will go haywire. Meaning, let's say you decided to modify your transaction. If somebody else decided to modify a transaction, there is no way we can keep up with all the change that happens and come to a state and say that this is the current state. Yeah. All right. Yeah.
You were talking about this platform exposure. So you are saying that a separate blockchain is being created and only the hash part is going in adding the actual main blockchain. Can you just tell me how validation of that works?
Okay. So the question is, how is the off-chain validation going to happen in the main blockchain? Okay. So we are recording all the transactions in the separate chain. Okay. In the
So
off.
it is being validated separately and added to the blockchain in that separate blockchain.
Yeah, in that separate, consider it as another layer. So you have your main blockchain layer, and you have another layer that's specifically for your payment network, and that records all the activity. And I say, after a certain period of time, let's say every 12-hour interval, I'm going to record this to the main channel, to the main network. What I do is, after the 12th hour mark, I'm going to get the hash of the block at that point. That will be the root block. And then, so if I do a hash of this block, it is going to prove that all these transactions that happened prior to that is valid, meaning it will be recorded. So if I were to take this hash and then record to the main network, that's actually like saying all the transactions that happened in the off channel happened.
No, that's not. So you are trying to add this hash pointer to the main block, right? So the nodes have to announce that this transaction usually it happens like the transaction is announced and the nodes like at the block. So how is it validated?
It doesn't announce all the transactions happened here in the main network. It doesn't
Just the
announce
hash.
just the hash. Only that hash is sent, but this blockchain is also preserved, but it is a separate chain. That's the point. So let's say out of the 1,000 nodes, okay, this off-channel payment is being processed done by like 100 nodes out of it, and only those 100 nodes will maintain the second blockchain. Only those nodes will be able to validate the payments that happened here, but always prove that that this is valid by the hash in the main blockchain. Okay, so whatever we are talking until now is the public blockchain space. So where where anybody can come and join the network, without any permission needed or without any. So this is the public blockchain. So it has this scalability problem that we talked about, and the consensus. Consensus is nothing but everybody agreeing that that this is the current state. Meaning, if one node has 10 blocks and the other node has like 9 blocks, I'm making things simple here. It doesn't actually doesn't mean that one node will have 9 and another node will have 10. So if one node has 9, the other node has 10, and the other node has 9, so on and so forth. all the node has to agree that this is, at this point this is the state. Okay, let's say at 5:15 in the evening this is the state. So everybody has to agree that this is the correct state or this is the correct state. So that agree to that is actually called the consensus here. So different environment uses different consensus mechanism. So one is the proof of work. That is the main consensus mechanism that's being used in most of the public blockchain networks. And remember I told you that the block size is limited. So because of which there's only so many transactions that can be recorded in a block. So if you can have 1 megabyte block, it can accommodate only 1 megabyte of data into that block. So that is a problem. That is a constraint. There's a huge debate in the Bitcoin network about increasing the block size to a 2 megabyte, and it didn't happen. People didn't agree. So it's a political agenda from some parties in the system, and so it didn't happen. So even changing from 1 megabyte to a 2 megabyte would have been successful, but would have alleviated the problem. May not be. So, and formal contract verification. Okay, the smart contract is once it is written, it cannot change in a sense. So let me backtrack a bit. So this smart contract has to be written. Okay, so because that is the code that's going to govern the network, like how the network is going to behave when certain things happen. That is governed by the smart contract. So if something were to happen, some bug were to have introduced in the smart contract, and that is going to cause a lot of problems. So this formal verification is nothing but being able to say that this contract works as intended, without any side effects, and given this input, this will be the output always. That's the item potential. Things like that. So this formal verification is hard because of the nature of the software. It is hard. So then, these are some problems that are being faced in the public blockchain network. Okay. So coming back to another form of blockchain network, there is this permission blockchain, which is now not the public blockchain, but where you need some kind of invitation or some kind of permission for you to join the network. So these are things that are looked at the enterprise level. So if I were to, if RBI decides to blockchainize things, and they will not go to a public network, so, because they want to know who does what activity. In a public blockchain, I don't need to associate my ID with my the virtual ID in the system. That is not a very good property for the central bank, for any enterprise for that matter. So they want something where they can mandate that only these people can join, and they need to meet certain criteria for them to join. Okay. So only trusted parties are given permission, and there is this sort of digital identity given to each actor who is going to participate in the system, and remember in the blockchains, in the earlier example, the distributed example, where everybody will get access to all the transactions that happen. That may not be a good property in certain system. In my example, in the stock market example, for that matter, if one company were to trade with another company, they make a OTC trade, like over the counter trade. That cannot be disclosed to everybody. So that has to be that secrecy has to be maintained. Like if Goldman Sachs decides to buy something, if another investment bank decides to buy some shares of Goldman Sachs, that data cannot be out in the public. So for those things, there are certain privacy that is needed. So for which, there is this concept of subspaces where certain organization can decide to form a small subspace between themselves where they do transaction amongst themselves, but that is not known or made visible to everybody else in the network. So yeah, and in the permission space, they don't generally go for the proof of work or proof of stake sort of consensus. So what they go is for the Byzantine fault tolerant algorithms. So given a network of n nodes, it has to n by 2 minus 1 nodes has to agree that this transaction happens. So that's how that algorithm comes to a consensus. If these many nodes agree to that, then that becomes the new block. Okay, and this public blockchain has a incentive mechanism, for people to act in a good way, and this is sort of the contract. So in a public blockchain, there's no privacy. All the transactions are sent across to everybody, so there's no privacy, and so this is the reason enterprise go or a permissioned blockchain system. And there is this another thing called consortium or federated blockchain system. These are systems that multiple entities, multiple companies or multiple organizations come together, and then they decide to form a federated system or a consortium, and then they run a blockchain system for themselves, and in these kind of system, you definitely need some kind of permission or invitation to join, and those will be trusted parties. Now they will not allow anybody on the outside. That party has to be known, and the consensus here is controlled by a certain number of people. Let's say RBI does a similar network, and they might as well say, I only create new blocks, and I will be the one who will write new blocks, who will create new blocks. So those sort of flexibility is given here. And why would they want to go for a blockchain based system for these use cases? Mainly to reduce the transaction cost. So when different parties trade amongst themselves, there is still a transaction cost because it has to go to another central body and then come. So this is to avoid the risk that I told you about earlier. So those transaction costs can be minimized, and data redundancies. So different organizations have to maintain their own set of data. Let's say if I'm an enterprise and another enterprise, we decide to trade, and I will maintain a set of records that I did something, did these many trades with the other guy, and similarly the other person will also have to maintain. So that data redundancy is there, and then this data has to be reconciled. So every day, now both of us will come together and say, I did so many trades, do you have all these trades? And this guy will say, I have so many trades with you, and do you have all these trades? This sort of reconciliation has to be done, and to improve efficiency. So all these reconciliation and all this data redundancy can be avoided in a federated system where all the data amongst themselves are shared, and there's only one source of truth. We don't have multiple copies of data lying in different places. So examples of which are R3. R3 is a consortium between different banks like 24 banks and Corda. Corda is something similar to this, where they're trying to onboard different companies, different banks into their system. Any questions so far? Yeah.
Lots actually.
Okay.
The permission to blockchain, let's assume that it's on Ethereum, the public Ethereum blockchain. Is it so? Like,
No.
no. So how will it be? Where will it be?
Okay, so if I decide to, if I'm the consortium leader, if I decide to say that the four of us are going to be part of the network, this will be between amongst ourselves. So he will run a certain number of nodes, he will run a certain number of nodes similarly, and I'll run a certain number of nodes. All these will be connected together, and this is a separate permission blockchain. Only this five of us will be able to participate and will be able to see.
What is subspace?
Okay, so let's say the five of us are in that network, and these two make a deal, and then they decide let's trade amongst ourselves that cannot be known by the other 3% in that same network. So they will go ahead and create a subspace for them. So the activity that happens in that subspace will be limited to that subspace. It will not be sent to the nodes that we, that the three of us wants. It will be sent only to those.
Will they use their nodes or their resources, or will they use only those particular resources?
Okay, so there is a certain distinction. So when I say the resources being used, the transaction has to be validated and endorsed. So the endorsement is something these participating nodes will say that this transaction happened and this is the output of this transaction. So and we all agree to it. So that's an endorsement. Okay, and validation. Once an endorsed transaction is sent to other parties, they will be able to validate that okay, this happened, this is the input, this is the output. So this endorsement will happen only amongst themselves, but and also the validation. But the state change and the addition of blocks will be sent across to everybody. That is the that is the essence. But the block will not have the transaction data that happened. So it will not have who traded with what. Those information will not be there.
Create a separate ledger for themselves.
Yeah, there will be a separate ledger.
So but this because let's say we three are doing a transaction, and let's say we two are partners. So we'll just write a transaction wherein you are sending us 20 lakhs, and we both will approve. Since we are the majority in all the three, we'll get the transaction approved. Then you will you will be paying us 20 lakhs. You get it? I'm writing a transaction wherein you pay me 20 lakh, and we two are partners. So we say that this transaction is correct, and we vote for that this transaction is proper. In that case, you will give us 20 lakhs without you even knowing that.
Okay, so remember the endorsement policy I told you.
Yeah.
So when we create a sub-channel like that, the endorsement policy will be in a way that the three of us has to agree.
Okay.
Yeah. Okay. So yeah, so this is, and so this Hyperledger is an open source project that is governed by the Linux Foundation. So this is the project that I'm associated with. I'm a maintainer in one of those projects. Hyperledger is an umbrella project where there are n number of projects under similar to Apache Foundation. So I'm committed to Fabric and the Blockchain Explorer. Blockchain Explorer is what DTCC sponsors and does the code contribution and also manages the project. So to give you an idea of what the Hyperledger Foundation, this thing came out the need for a standard application platform sort of thing for blockchain applications. So the Linux Foundation saw it to be this is something that we should govern, and they took on the project, and it's being run by the Linux Foundation, and there are like 100 members in it. IBM is a member, DTCC is a member, so there are, and these companies also give money and also does support contribution. So let's stop at this. I can answer more questions. So I had prepared something where we go in depth into the Hyperledger Fabric activity, but I figured will not be relevant here. So we'll stop with this and then I can take more questions. If you guys.
In short, what is the project about? Recently I just saw news about Hyperledger in India, so I was curious about what that is.
Yeah. So Hyperledger is a project that runs. Is a foundation that runs these open source projects, where Fabric is one of them. Fabric is a distributed ledger platform. Think of it like a database. So if you want to write an application, you need some kind of database and some kind of middleware for you to write. So this provides this infrastructure for you that is going to take care of this peer-to-peer messaging, the consensus, and the identity. All these things. It is going to provide you this platform where you can write your application code, where you will write your application code and then deploy it on the blockchain network and run your distributed ledger application.
Like decentralized.
Yeah. Yes.
Can you set rules on what a valid hash is?
What a valid.
Like the hash should be starting with this number of
Okay.
zeros.
So, I think this question is more towards the proof of work algorithm that's being used by the Bitcoin and the Ethereum network. Okay. So when the network has to validate a new block, meaning create a new block, it has something called the difficulty level. Okay. So remember I told you that a block will comprise of all the transactions, all the pending transactions, okay, and it adds something called a nonce. Think of nonce as a random number, where you try out different things, and the output of the hash should be less than some number. Okay, a hash is a hexadecimal number. Hexadecimal number. Let's say if it should be less than certain number, that means it should have these many zeros, in the beginning of the hash. Okay. Let's say if it should be less than 10. Okay. When 10 is represented hexadecimally, it will be like something like that. So if I say it should be less than 0.8, okay, so they will try out different nonce here to come up with the hash that is less than something. So I think in the Bitcoin network, it has to have about 20 zeros in the beginning or something like that. So, and again, this difficulty level is adjusted on the network by itself. Ethereum adjusts depending on the new block creation time and so on.
So this is the reason behind the computational time.
Yeah, this is the reason behind the time it takes to compute this hash by changing that nonce. So it has to try out different nonce to be able to find out what the accepted hash is, and then announce it to the network. All right, thank you. So these are my contact details. Things will be shared later. So if you want to get in touch with me, you can find me here. Thank you, guys.
Thank you, Satheesh. So Satheesh will be around for the networking section as well. You can ask any more questions if you have any at the end. So over to Seetharaman without much delay.
Am I audible now? Last row. Do I need mic? Okay, fine, thanks. So how many of you here are software developers? I mean, doing some software, some hands-on software. Okay. So others never tried any software development, right? Yes or no? No. Okay. So can anyone decode this pattern?
Hypnosis series.
Shubhanos? Is blockchain is as simple as that. If you are able to decode it, it is very simple to decode how blockchain works. I can say in that way. Don't see about a blockchain as a transaction or a currency and all. It is not like that actually. See, why we developed software? Why we actually invented software? The basic purpose of software. Why? Why we need software actually? Day-to-day basis, we are using a lot of softwares. Why we need softwares? Louder.
Automate something. To automate something.
Okay. To automate, you need something. With that only you will automate. What is that? Whatever we say, end of the day, it's a data. We develop software to store and retrieve data or process data or manipulate something. Blockchain does the same thing, but in a different way what we traditionally do. A software comprises of 4 things major: a client, a server, and database. The client can be a browser or a mobile. Anything else you see in this stack, any software you see, only 3 things: client, it can be a mobile or IoT or switch or button, whatever it is, and a server and database. We store data in database, we retrieve data in database, right? That is what we are doing with software. Any doubts on this? Are you able to understand this, how software works basically? Since most of the people never tried any software, I just want to confirm that. As for the software developers, when we start developing any software, we will not look into how compiler works. We will not do that. We will try to write our hello world. We will not go and dig deep and drive how compiler works, how the code is building and all. You will not worry about it now. Once you are comfortable with your programming, you can dig deep how compiler works, how you can optimize. That is my perspective. As a developer, you should get comfortable with what you are actually developing, how it works, rather than getting into the compiler first. So the agenda is going to be like why we need blockchain, why people are speaking about blockchain. And already we have tons and tons of softwares that are running successfully. We don't have any issues with software. Are you facing any issues with your current mobile apps or web apps? What is the things they are talking about? Why we suddenly need to move everything to blockchain? We should understand the basic thing, why we need this blockchain. Then only we can realize what is the potential of it. It's not about going and doing this is a blockchain does. It will not help you to develop any application. You should understand why we need blockchain first. Then the second thing, how blockchain works. We have 10 different browsers, right? 10 different browsers work differently. But there is a common mechanism. That common mechanism you should know to develop any software for browsers. It's not about this browser works in this way, so it is not necessary to work in the same way in the other browser. So understand the basic layer, how a basic browser works. If you open an HTML page, it opens. But there is a similarity, but there is a difference also. Chrome will behave in one way, as well as Safari will behave in another way. You cannot expect every browser behaves in the same way, right? Are you agree? You see a date picker works in a similar way, and it will be completely different in IE. Sometimes it will not open, right? So another thing is how blockchain works is very important. Then how in depth it is working. You do not worry about the Chrome compiler or V8 engine. How it is compiling, how the bytes are converted. You do not worry about it now. Once you are comfortable about to develop a hello world, then you can dig deep and find out the difference. Just try some hello world in anything, then dig deep. Third thing, what can be developed using blockchain? If you understand the first and second, then only you can think about the third. If you directly go to the third, it will not work out. So why we need blockchain? I need one volunteer. Anyone? Anyone? Any one volunteer I need. Okay. So here what you are going to do, it is a simple exercise. The exercise is like, the name is random number story. The person can ask any person any random number. You have to say your name and any lucky number or random number, whatever it is. You can ask 5 persons random number, but you have to write it in this way. In BFR the slowness. So you can raise any one person, ask their random number and their name. Yeah, you can have the mic.
Anshuman and Nizamud 2003.
What is that?
Anshuman.
And 3, right?
Yeah.
Okay.
M.
10.
Raja 27.
Okay, last row, last person.
Ravi 18.
Johnny. So now we have this data. This data can be developed in any software, right? We give the input, it will be stored in some database, right? So think like that is a database we have right now. Right? This is the data and this is the person who, the processor, server, whatever it is. You written in Java or PHP or anything you think. And now you are the clients. You gave the input, he processed it and stored it in the paper, right? So this is how any software works. If you want to get Johnny's number, suppose that person wants Johnny's number, he has to depend on him, right? If anybody wants Anshuman number, who will you ask? To whom you will ask? Anshuman is not there, he went out. Database you have to ask. You are completely dependent on him, right? Now its data is completely centralized. And Anshuman is not there. Anshuman told number 3 and he says number 13. Why? Because he has the authority. He is having the control of the data. So he can handle anything. It's like a mobile app. You are putting all your money transaction to one mobile bank. But you don't know what bank is doing with your money. Do you know? Do you know you have tons and millions of money in your account? Do you know what bank is doing with the money? Do you have any control over it actually? No, right? One day the bank will come, I deposit and I put into the stock market, everything gone to go for you. Can you do anything? You cannot do anything because there are a lot of hundreds and 20 lines of terms and conditions you agreed earlier. Right? We don't have time to read that and all. Right? That's how we work actually. We will not read that 100 pages, 100 pages. So, and also it is getting crashed and it's burned out. Now data is nowhere. We lost completely. That is the issue with the centralized system. So,
What about the backups that we have for the
think about entire software collapsed. It is centralized. Even if you say backup and all, it is the same company. You say about scalability, I'm making the sharding, backupping, end of the day it's a database. One database which is controlled by that bank. Right? Nobody is having the call.
Okay, and when you say the bank collapses or whatever, there is something called as government which handles.
Yeah, but you are already suffered, right? To get back your money, you have to suffer. You have to wait. Bank will do things. You have to wait, but it's your money. You lost it, but you have to wait for someone to take action. It's not your fault because it is decentralized. Centralized, right? You didn't do any mistake. Yes.
You are dependent on somebody else.
Yes. You are using the centralized person's services, right? Like bank. For bank, it is completely centralized. You are using their services and you are paying the money for their services. And also you are giving your money, sharing all your data. Governments, for everything they are dependent on government. If you want to change your land patta to someone, you have to go to the government offices and stay there for hours. No other options. You cannot do, okay, call 10 persons, I am giving my land to him, you cannot leave. Someday, another 10 days, he will come back, this is my land. So we are completely dependent on government to do all the notaries. Every approvals, you are dependent on government. But that's okay for people with a crowded of 10 million. It is growing exponentially. And government will say no budget, it is going in loss. Then your work will not happen, but you already paid for something, right? It's not your fault. It is something changed about how it is happening now. That's why people are started talking about blockchain. This has some potential, can make this thing smoother. And service providers. These are the service providers we are heavily dependent. If Amazon says this is the price you have to pay, if Amazon is the only service provider, if Uber says rains flood, I don't care, this is the place, if you want to use it, then go. You are dependent on them, right? So these kind of scenarios, it is not the only centralized system, there are a lot of things. This is simple examples of it. I'll say, we have set up our CCTV cameras, right? In our home, we have set up our CCTV cameras. It is stored in some storage space, right? If you see in many of the cases, CCTV footage are missing. Why? Have you ever heard about CCTV footage will be missing? Because it is stored in one place, someone removed it. If 100 homes are there, 100 homes have a security system and the servers, which is all the data in the 100 CCTV will be shared in 100 machines, right? It cannot be erased. Right? So when there is a centralization, there is a trust issue. Something happens, he has authority to change it. Since it is, the authority is not in your hands.
But where is the privacy? Where is the privacy?
That's why people are calling about the cryptography. That will bring the privacy.
Excuse me.
Yes.
Okay. All the examples you gave now is from the perspective of the client, right?
Perspective of?
The client,
Yes.
the end user,
Yes.
whatever that's there in that stack. So consider I'm the server. I need to control all the clients. I need to monitor them. So the centralization needs to be there, right?
What kind of application you develop defines that. It's not every application needs the monetization. How you are, what the data you are going to handle, whether it needs the monitor, you see, there are different things. If you go in deep dive into that, right, it will be keep on going. So
private blockchains can be used.
yeah. So I don't want to speak about consortiums, public blockchain, private blockchains. I'm going to simply give you the Pythagoras theorem. You can use it for whatever purpose you want. So centralized systems are low security and also single point of failure. It's mutable. Someone can change it anytime. And trust is also very low. So these are the reasons. It is not the only reason. This is a potential reasons. We can move on to the next thing. These are you cannot tolerate low security and low trust, right? You will not do business with the person who is having a low security and trust. There is something need to be changed. Then people found out there is some technology which can support this facility to move on. That is called blockchain. So now we get into how blockchain works. This is a similar kind of a game. I need some 5 volunteer systems. 5 people. You have to come if you are interested. Boring.
Excuse me. Before you get to this, I just want to ask, do you think the government or authorities will implement blockchain?
Definitely they have to do. They will be forced to do it.
But don't you
Not
think,
today, but in near future.
But don't you think using this blockchain, the people getting removed are middlemen?
See,
Like,
you will not feel the application is running on blockchain. That's what I am telling. It is like this. The backend part. It can be a Java application or whatever it is. You need not to worry about it.
Yeah, as
You
a
will
customer,
interact
I
with
don't worry.
clients.
Yeah, as a customer, I have nothing to worry. I don't care how my money flows. But as a bank, if this implements, bank will go out of business, right?
Why should they go?
Yeah, this is peer to peer. Why do I need bank? Why should
Not
I
a-
pay a cut to bank?
No, we will not do that.
No, but this is the. I think like this is the main reason of.
It's only applicable to financial institution is what you're saying.
Yeah, I'm
but
asking-
blockchain is for all like retail, governments. It's not just for banks. So only if it's going to be the point of finance, then banks are getting involved.
Just to pitch in, actually, in this budget, NITI Aayog has already mentioned that they are investing in blockchain as well as in AI mentioned.
And even in the banking space, right, you can get rid of all the intermediaries and the settlement could be faster if you use such kind of system, blockchain.
But
It's not that you can
replace bank.
completely replace the bank.
Yeah.
I think they will not be doing that.
Exactly.
Yeah, but the applications could be.
So like where are the places where cloud falls like short in these kind of scenarios?
Clouds, all your blockchain
Definitely, see,
systems,
Google Cloud system.
blockchain infrastructure will be used. I mean, blockchain infrastructure will be set up in cloud.
Yeah, that has to be set up on cloud. That's fine. Like we also have this individual nodes playing a part in it. Like even my system can be a part of the blockchain.
See, the
network that
individual
we are
nodes, whatever you talk about, right, it will be said with finance. When you do a business, when you do a money transaction or currency kind of a transaction, when you go to enterprise, there won't be any individual nodes will be participating in it. It will be a business to business. It depends on the, see, that's what I am telling now. The blockchain is applicable to everywhere. It is not only for finance or money.
No, that's true. What I'm telling is like you told that a decentralized system should be present, like not basically centralized. Even clouds have decentralized systems. It's told that Google, any data that you store, it has
That is not decentralized. That is distributed.
Distributed as well as
Distributed is different from decentralized.
Yeah, correct. If we take like fog computing into consideration, that is a decentralized central base.
Maybe there are other application of blockchain.
But they don't use blockchain consideration.
They might not aware of it.
That's what.
Yeah.
So like, where are they falling short, and we want blockchain to copy?
Maybe there are lack. Yeah, again, you are going to the centralized person who identified it, right? He is not open source it. If it is open source it, people tend to use it.
No, like cloud computing is there.
Cloud computing is
fog computing.
Cloud computing is completely different.
That is, yeah, distributed systems.
Yeah.
But the fog computing that exists is what?
I'm not getting you.
No, like,
You are doing much more clearer to your question.
so like what I'm telling is like you told about decentralized systems. Cloud
Okay.
computing works basically towards decentralized systems only.
Cloud computing is distributed, not fog. Okay. Okay.
Okay, so just I want to know like where did fog computing fall shorter that we need to go towards blockchain?
See, fog computing is like sharing a data with your existing mechanisms. The sharing the data with security, all those things comes with blockchain. The security you have to build in fog computing, whatever security you want to build in, you have to build your own security models that can be hacked. That can be hacked.
Even privacy issues are there in blockchain as well.
Yes, we agree that. We are not saying there is no issues in blockchain. We can go and deploy a full-scale application tomorrow. We cannot do that.
You cannot do that.
Yeah, that's what I'm telling. It's just like there is an opportunity to use these scenarios to develop
You're
applications.
starting towards
Yes.
it.
You are thinking like I invented internet today. I'll launch Facebook tomorrow.
So
That will not happen.
that cannot happen.
Yeah. So I need five persons. Seriously. Anyway, you can sit in your places. No issues. You take one. Only one. So okay. This game, it's like how blockchain works. I'll try to make it simple. You identify this pattern, right? What is the relationship between this number and this number? Without do these numbers, it will not come here. So it has a link with previous number. Right? That's how data is formed. I'll try to explain much better. So, okay. So there is a box. I'll ask any four persons with some random number. Okay. So since I'm the starting of the game, I'll put my own number 2, and I'll for the game starting, I'll add my number itself. I'll not ask anyone else. I'm putting the number 2, and I'm putting my name Sita. Okay. Now any number, any lucky number. 11. Okay. Yours. 10. 6. So who are the 5 persons actually that have the paper? Okay. So we have to say answer for it. Anybody can say first, they will get the answer.
23.
23. 23?
4 7 square rupees. 49.
65. You will not get the opportunity to say only that 5%. That's why I asked only 5%.
65.
65. Who said first? Okay. 65. Then now you can choose any 2 numbers from here. What are the options?
10 and 6.
10 and 6. Okay, add it.
Add 16.
16. You have to add my number also.
18.
18. What is your name?
Harsh.
Harsh. So you will get 50 rupees in your wallet. I'll send it tomorrow. Okay. So now the again same. Okay. Any lucky numbers?
7.
7. 7.
23.
23. 5. 5. Okay. I think last week Elon Musk launched the Falcon rocket, right? What is the serial number? There is a serial number for the Falcon rocket. Do you know that number? From five people. There is a specific version of the Falcon vehicle.
10. Falcon 10.
No, you are little close to that.
No, Falcon Heavy 10. That's what.
It's 9.
9 was the previous one, this one was the 10.
This one they launched 9. I think.
10.
Falcon 9.
Falcon 10.
Falcon 9.
Okay, there is a controversy. We go on for the next question. Who is your defense? I mean, who is our India's defense minister? Okay, so you got the opportunity. You can choose any two numbers or any three numbers also. If you want to choose three numbers, you can.
7 to 5.
7 and
2, 5.
no, it's 23.
Then 23 and 5.
Okay, add the two numbers.
28.
Then you have to add the 18.
46.
46. And then so on. So if you see this, it will be keep on growing, right? Only 5 persons got the opportunity to add the block. These people are minors. Whatever the term, it's minors. They are doing some mathematics, right? They are solving some problems, that is computation. And this is the block. We are adding the block. This is the root block or genesis block they say, but I don't want to use the word genesis. Consider it's a root block. This is the beginning of our chain. So and it seems like a chain. It will be keep on adding if you do the same process again and again, right? So the numbers is a transaction pool. So there are a lot of people say a lot of numbers. Some data, right? This is a transaction pool. It has 3 numbers. Some people choose 2. Some people choose 3. But once we added this is the second block. It keeps on adding. But any block is related to the previous block, right? This is how blockchain works. You cannot go and change this block. Now I have chosen initially some 13 and 14. Now I want to change it to 12 and 13. You cannot change because this and this will get affected. The result will not be the same. That's why people say it is immutable. That is called it is security. Data is up and down. You cannot go and change it in between. Understood?
So there's only one starting point.
Only one starting point. Or one chain, only one starting point. Understood? This creating, we are saying like simply added, right? 7 and 12, 9 and all, and then we added the previous number. They will not do directly like that. They will pass some cryptography functions, get some A, B, C, D, X, Y, Z, some big number, then they will add it here. I don't want to make it complex, just consider this as a number right now. Once you develop some kind of a hello world, then you will get to know this. You will not skip this. But consider this, we took some transaction, we added it, then we added with the previous block, then we have created a new block by doing some mathematical calculation. Right?
So who decides that mathematically?
That is by the system. I am running the system, right? I decided the system.
So you are the first.
Not I am the first. It's a kind of network. Now I decide the first question, right?
Who are you?
I am the genesis. I mean, I am the origin of the network.
Origin.
But I will keep on changing. I ask this question now, then automatically other person will ask the second question. That's how it will change. But now I asked all the question by myself. It will be keep on changing. The network decides what is the next question. Right? You understand? Any doubts on this? Any doubts? I just picturize the same scenario what we did. So you see the block, then current transaction will be in the white color, the previous and the result will be saved in different color. The result will be added to the next block. This is how the data is linked. End of the day, it's a data. Don't forget, think about too much about transactions and all. Yes.
You did all the hard work and you created the network and you distributed everything. That's all fine.
Yes.
So what will be your problem? What will be your problem?
If I keep on, myself I am solving any questions, right? I'll get reward. That's why I told him you'll get 50 rupees wallet in your wallet, right? Likewise, for every adding a new block, I'll get rewards. This will be applicable to only the financial applications. When you go for enterprise applications, this mining reward will go away. See, when we are doing retail, I'll say a simple example. Next we can see. So that is a complete ledger or blockchain. And this is a genesis block, we started with that. And the new blocks keep on adding to the list. It's immutable. You felt that it is immutable now? Are you able to understand that now? It's how it is immutable. No downtime. 5 persons have the data. They have written in their paper also. But I missed that thing. Every minus has to add the same circle. Whatever I did here, they have to write in their paper also. If I click, if I remove one paper, other 4 persons are already having. They cannot fake it, right? It is not like a one single point of failure. And also, one person changes one particular data. Other 4 persons have the truth data. They can say, you are lying. We have all 4 truth values. Someone, if 3 persons are joining, then changing the data, then the network is compromised. That will not happen in blockchain. It is not like here we have only 1 5 person. There will be a millions of persons connected to the node. That will not happen. Secure data sharing through the cryptography mechanisms. We need not to discuss about now. It will be a very depth topic. People are doing PhD in that. We need not to discuss about it. We will simply use it. And trustless. You need not to trust anyone because you have the data. It is truth. And it's transparent. Everybody has the same data. You know that. And up and running ledger. The data is only adding to the end. You cannot push the data in behind the, between some chain. Okay, I will take a real world example of a software mechanism, how it works, and then how we can change that using a blockchain. It is a simple analogy. There is no controversies or fights again. I am just trying to explain how blockchain can change a thing which is already present in a traditional model. How many have products ordered online? Okay. Many. Then you will have a lot of knowledge about this topic. Okay, I am thinking myself. I am doing an online order. I am ordering an iPhone X in Amazon. Okay. And Amazon stores all the data: my name, address, phone number, email ID, and my what is the product I ordered, what is the quantity I ordered. Everything stored in the Amazon's database, right? Do you have any doubt on this step? Doubts? Okay. Now Amazon sends the payment request to bank. Bank stores the order number, the corresponding payment, all the data in this database, their own database, right? And then Amazon notifies the seller there is a product is ordered on your store, and you have to send the product to my warehouse, right? Then it notifies logistics. There is a product ordered, you have to deliver it to customer, and he is also getting some data from Amazon. Here, Amazon is the only center point of contact. They will not have connection between those people, right? And also, it is not necessary. Seller need not know about the bank's data, or FedEx need not know about bank's data. It's vice versa, right? They need not know all the data, but they have some common shared data. It's order, customer, address, and phone number, email ID, right? But again, this completely centralized with Amazon. Everybody depends on Amazon. There is no problem on it. It's running successfully, right? I received a product. One day I feel my phone, iPhone is not working properly. I want to cancel, right? How many days it will take get you a refund? At least a week. When you order a product, your money is debited within 10 seconds. When you cancel, it takes 1 week to come back and get your amount. Is it not a problem? Right? Think like a cash on delivery thing. Cash on delivery, when you cancel, you will get the amount immediately. I think so. I never tried it. Is that so? Or it will happen another same process. 7 days it will take to return. See, things you paid cash, you cancel the product, you given the product also, but you will take 1 week to get back your amount.
Because they want the return delivery confirmation.
Even the return delivery confirmation, again same time, right? That's what people are telling. I never experienced that. Is that not a problem? Because it is centralized. It's not about Amazon want to delay it. It's a process, right? Because he has to notify seller what is the problem. Then the seller notifies, okay, I'll get back the product again. Then again he has to notify the logistics. Logistics has to connect with the people and collect the product and then confirm to the warehouse. The product is returned. Then Amazon notifies the bank, return the amount to this person. It takes a lot of time and process because they don't know what happens to the particular order, right? any point of time, the truth value is only with Amazon. All others know when they interact. Right? Doubts on this? Doubt? Okay. If there is some common shared thing between Amazon, seller, logistics, and customer. I mean, customer, forget about customer. Only it's about Amazon and all 4 people. They are able to share particular data, order status, and customer name, and mobile number, some others. They are able. Only this data is needed for all the 4 persons. Order status is needed for all the 4 persons. If it is cancelled, logistics without interpretation between the Amazon, they can go and collect. Bank immediately return the money. Right? Customer will get benefited. Right? That's how the blockchain will come and. Can you come again? No. So all the data is Amazon. Right? All the customer data. But the order status, mainly we need order status needed by all the 4 persons. And customer name, maybe address. To share to the bank address, not a problem, right? We will not worry about sharing address to bank. And customer name, anyway we are doing a bank transaction, we are sending the data. Seller knows that because he need to dispatch it in that name. And logistics also has all our data, you not worry about it. If these 4 data is shared between all the 4 persons, if order status is changed to cancel, bank automatically knows this order is cancelled, I can refund it. Or else wait for some time, logistics goes and collect, he changes the data, product is returned, I receive. So bank need not wait for the Amazon confirmation. The status changes to product is received, he can refund it immediately. Right? Right or wrong? This is a one single pain point of a customer which can be solved using blockchain. So there are a lot of things are there we can solve. How many of you see election? I mean, before election, people will release something, right? Everybody will have this percentage of winning possibility. What is it?
Election manifesto.
Election manifesto. Exit polls. Every telecast will have a different opinion. Why?
Biased.
It's biased. Right? So, will it be impactful if that system come into blockchain? They cannot bias. They can pull their own people and pump the data, but that is an extent, right? They cannot do it. When you make it that exit poll in a public place, then you cannot bias. Right? These are the scenarios where blockchain will perfectly fit and solve the problem. How many of you see tracking the government's budget plans? Government is every year releasing millions budget plans. Do we have any track of it? How it is spent? We don't have. You don't know, it might be allocated to you also. You don't know whether you received or not. There is no track. How it is spent, who spent it, we don't have a track. These things can be injected into blockchain. Every spending will have a data. Who spent it? We can make it in other ways also. If there is a budget allocated to this person, unless until they reimburse it, that fund will not reduce. Right? So you are allocating to some 100 people, they have not used it, what happened to that fund? Next year budget comes. So those things need to be regulated, that can be done using blockchain. It is a very vast area. Think of it about wherever you need 2 businesses interact or 2 persons interact. You want to share data securely, that places blockchain will fit. Forget about this mining and transaction and all. It's a psychology more than a technology. It's a kind of, they form a network between all the 4 peoples. They transact data using blockchain protocols. The protocols will vary, depends on the platform which we are going to use. Sometimes it will be a proof of work, sometimes it might be a proof of stake, sometimes it will be ZK and SNARK, sometimes it may be endorsing policy, sometimes it may be notary. You don't have to bother about it. It comes when you choose what platform you are going to develop. End of the day, what is the data I want to share between 4 these people? That you need to define first. These 4 data should be shared between all the 4 persons without any problem. But I will keep particular data with only Amazon, particular data with only bank. Right? We cannot share the credit card details to the seller. right? There are decentralization, but we will keep the data secure. We can do that. That's why the different blockchain platforms comes. One is having some limitations, other comes with the I resolve this limitation. It keeps on evolving. It's not grown completely. And I mean, as Satheesh told, now blockchain 3.0 is there. When blockchain 10.0 comes, then it will be in another level. Before that, as a developer perspective, you should do right away develop some hello world. That will help you really understand blockchain rather than seeing all the PPTs whatever I show. So blockchain in business, where it will get affected, right? Supply chain. Supply chain involves 4 and 5 people, right? The person who is producing the product, he is selling to product to the other, carrier. Then the logistics will take to the another world, another end of the world. There are 4 or 5 businesses. Because this carrier is a small business, he only deliver to the port. There is a Mears who will deliver the container to the other end of the country, other end of the world. He is doing his own infrastructure. But that product status need to be maintained at one single time, any point of time. That travel should be a one truth data. What happens to this product? What is there right now, right? Insurance. Right now, you are buying an insurance policy. How easy it is? You will come to your home, right? They will come to your home. They will give the policy in 10 minutes. They will collect the money in before 10 minutes. Then they will go away. How much time it takes to claim it actually for anything? Sometimes they don't know it is not able to claim also. You will not read the terms and conditions, right? They don't know you are not eligible to this policy also. End of the day, they will tell after collecting all the premiums, you are not eligible to claim this policy and all, right? So insurance, if we have implemented a solution to a Singapore-based company, it's like in Singapore, like our Aadhaar number, they are having the IC number. Every health record is having a centralized repository. You go to any doctor, data will be stored in their repository. We developed a blockchain application. You buy an insurance from the insurance company. The data will be registered in the blockchain. Anytime you go to a doctor, you take a treatment, it is automatically initiated. The claim will be automatically initiated without your involvement. Your payout will happen in one day. You go to doctor, you will come back, you will get your money back in your account. Those kind of issues we can solve with blockchain. Banking, many people say it's currency, peer-to-peer. Okay, that's fine. Banking is also having a lot of settlement issues. When we do a transaction from ICICI to another bank, like now we have resolved using UPI. The UPI will be, change into blockchain in similar way. Right now we can say UPI is a kind of example for blockchain data transfer. It's a peer-to-peer. As a user perspective, we experience, we are giving some ID, we are transferring the money. But removing the RBI from the scene, then it's blockchain. And governments, all the government policies might be put into blockchain. And food safety, we are buying food products, right? We are seeing that food product, it is having all the data about where it is manufactured and all. Do you really know that it is there? Do you have any, many products give you the ability, you do a QR code scan, you will see all the data. Whether all the products are doing that? No. If the same 2 serial numbers, 2 products can be manufactured, right? Some local guy is doing and getting all the serial numbers, doing the same thing again, you will not know. If there is, I ordered a product I purchased, then the entry will be changed. This product is already bought by someone, used by someone. There should not be any product created using the same serial number, right? Those kind of issues we can solve. If that data is centralized with again the same company, right? Someone can influence that guy who is the system admin of that infrastructure, giving him money, change the serial number to a open status, right? If it is decentralized, he cannot change it. So basically what we need to become a blockchain developer, this is a very important thing. Don't think about you want to be a PhD developer, PhD doing something in cryptography and all. You want to be a simple basic developer, you should know basic HTML, JavaScript. If you know the first 2 things, right, the first layer you can develop. You don't have to wait for anyone. If you know first 2 things, you can develop using the first layer using a blockchain. I can help you out within 10 minutes, we can develop a simple blockchain application. It's not a big thing like running Amazon cloud and then developing a Hotstar. It's not like that. It's very simple. First two things you know, we can develop a blockchain application. I said the Singapore example, we developed it in the first stack within 30 days. That is as simple as that to develop a blockchain application. Don't complicate yourself, it is a very big thing, we cannot do it. A computer, you know basic HTML, JavaScript knowledge, you can do it. And the second layer is another version we need to integrate with blockchain. It's not about only blockchain now. We need multiple environments, ecosystem to support this to bring us a product. So that's like, the first row is a Kotlin. There are multiple platforms, right? Every platform will support their own language. If you say Chrome, they are having the V8 engine. Firefox, they are having own, anybody knows that engine? Echo. And everybody has typekit. Safari is using something, right? Likewise, every blockchain can be created using multiple platforms. It's not about only one, using that one you can create. There are many softwares, depends on your need, you can choose that and develop it. This one is Kotlin. If you learn this, you can develop an Android application also, as well as blockchain application. And the other one is Go programming language. It is another functional programming language.
What did you say?
Go programming language. Using that you can develop Hyperledger, and using the first one you can develop CodeUp. And the Node.js will need to run your servers, normal web servers. You developed your HTML, JavaScript and all, and then you need to run it in a server, right? You need simple Node.js understanding.
What is the third one next to JS?
That is Solidity. Solidity. People only speak about Solidity. Other two things are there to write a smart contract. That is Triple N and Serpent. But Solidity is the preferred one recommended by Ethereum.
That is for front end.
Not front end. That is for the smart contract and blockchain. You developed your HTML and JavaScript. The blockchain part we have to develop, right? That is Solidity and Ethereum.
So front end is only HTML.
HTML and JavaScript. To say simply, developing
Can you repeat the what it is? Third one, smart.
Solidity.
Solid. And last eighth one.
831. Okay, we developed our blockchain. Ethereum. Okay. We developed our blockchain system, running our Ethereum, and we have written our smart contract. We have written our HTML and JavaScript. These two need to talk, right? We need a layer. That layer is the last one, Web3.js. Web3.js. We developed our blockchain system independently, and we have developed our client. Then we need a layer to interact between blockchain and our client. That is Web3.js. Using that, we will do every interaction with the blockchain.
What is that?
K is Kotlin. Kotlin is a functional programming language.
What?
You can develop Android, you can develop blockchain applications in Hyperledger. Not Hyperledger, CodeUp. There is a lot of applications, right? But if you know this, right, you can find a very, very good job. People will come to your home actually. Now in Chennai, if you are staying in Chennai, if you have this skill set, they will come to your home and pull you back. Seriously, literally it is happening.
Okay, Ethereum is.
It's a software to install.
Oh, Ethereum is the name of the software.
Yes.
Solidity is a language.
Solidity is a language.
So what is that? K.
K is a Kotlin is a language. Kotlin. Okay, fine.
So there is no database at all.
There is no separate database.
The blockchain is the database, right?
Yes, there is no separate database. If you want it, you can keep it. Nobody gonna stop you.
So everything will be front end.
Yes. So there are a lot of, as I told, there are a lot of platforms available to develop blockchain application. First one is UOS, and the second one is CodeUp. Ethereum is mostly right now people talking about, and IOTA, which is kind of a competitor to Ethereum, I feel personally. And Quorum is another version of Ethereum with additional some features. Hyperledger, and the last one is a Composer. To develop a blockchain application, if you don't have any programming language, right, the last one is the perfect option to develop a blockchain application. If you know the business, you can develop a blockchain application within 10-20 minutes using the last one, Hyperledger Composer.
Now, what is the first one?
First one is EOS. EOS.
US is still an ICO.
Yes, I'm telling. But still we can develop on top of it.
But what is the difference between CR, Corda or Ethereum? Because I only know Ethereum, but other things I'm not quite aware. So
Yeah.
do they also give a platform to develop apps for decentralized
Yes,
apps?
yes, yes. See, decentralized apps means sharing the data securely. That's it.
What is
Ethereum,
the first one?
first one is EOS.
So these are all IDs.
It's not IDEs, it's a softwares to develop the decentralized application. These softwares are the like
Is it like Visual Studio?
no, it's not a Visual Studio. It's like Java J2EE. JDK, sorry, JDK. Without this, you cannot develop application. So you can reach out my mobile number or email ID or my LinkedIn. I can help you to develop any follower or something like that. Technically, I can help. And I like to explain about we have launched a product. I am a software developer for this product. I mean, we have launched 2 days back in Chennai. Only to do if you want to do any meeting for 1 hour or half an hour, we can book a meetings in this. You will get a lot of offers. Thank you so much.
Contact me.
So in case you guys want their contact details, both of theirs, we will pass it on. And actually we are going to end the session now, but post the session, I would like to introduce someone right here. Santosh, if you can just stand up. So Santosh is the CTO of CoinDust. So they deal, so they are building, you're building a cryptocurrency exchange platform. So you can talk to him if you have probably any doubts regarding any of the cryptocurrencies. You can just get your doubts cleared with him. So to close, thank you so much Seetharaman and Satheesh. Thank you for being a part of this session, and all of you for coming here today on a Saturday evening, and most of the students here as well. So that's why we are trying to close this as fast as possible. And if any of you guys are looking for a payment gateway, you know who to reach out to. We'd be happy to help you out. So we have some rolls and soft drinks for you guys on the other side. So you can just go there, and now we open the session to networking. As I told you, there's Satheesh, Seetharaman and Santosh right here. You can talk to any of us or them. And thank you so much. Thank you guys.